Welcome to Analytics with Nags. In this video, we're going to explore about what is star schema and what is the advantages when you have a star schema. Let's try to check it out in this video. We are familiar with this architecture, like the ultimate aim of building the data warehouse is to build a dimension modeling, that is star schema or a snowflake schema. And the steps involved in star schema or snowflake schema remain same. The only thing is like the snowflaking schema, you have another level of dimension, and it's not actually the level, it is the another dimension linked to the dimension. We typically say the definition is like fact table indirectly connected to a dimension table via another dimension table. This is what the snowflaking definition is. This is absolutely fine. Before going to explain about star schema, if you're new to this channel, hit the subscribe button and press the bell icon for notification. Let's begin with understanding what is fact and dimension. So the ultimate definition is like what you want to analyze is your fact or measures, right? So to give you an idea, you want to analyze your sales. So what is my sales? What is my profit? What is my customer preference? Or how many customers I have? The count, the summation, the aggregation, the minimum value, maximum value. These kind of numerical values, that quantitative values, right? Those things are considered as measures, and these measures should be stored in your fact tables. Then what does the dimension mean? Dimension means by which you want to analyze those measures, right? So you want your total sales to be analyzed by location. In this location, what is my sales? And the location 2, what is my sales? By product, what is my sales? And during different period, what is my sales? So you are viewing the same measure or the numerical quantity in different perspectives, right? So this is what your dimensions is. So this should be stored in the dedicated table. If you consider location, then it should be stored in location dimension table, and product should be stored in different tables. So each dimension should be stored separately, and all this dimension connected to your fact tables along with the measures. This is what your fact and dimension definition is. So as we saw before, you need to understand the business process, identify the grain, and design the star schema. What should be in your fact table, what are the things you should have it in your dimensions. So assuming one of the functional area like a sales, and your sales fact should be designed like this. You can see here, this should be the key, like a location key. We do not have a dimension for it. So always it should refer to your another table, like all your master tables should be populated first. You have here the sales. The example over here is like, assume it's some supermarket or some hypermarket sales, and you need to design your sales in such a way that all your dimensions are linked. So you have your product table here, and dates and customer and different location. This is as simple as that. So these are the 4 dimensions you identified. So you will design this table first, I mean create this table first. Then you will try to populate this data, I mean the customer and product, date or location. So all the dimensions you will populate it first. Then there is a concept called surrogate key. I will explain about it in detail in our upcoming videos. So you will create one technical keys here. So those keys will be referred here. So typically this can be some biscuit, and this can be a chocolate. So these product names appear here. You will not store biscuit and chocolate. Instead you will store this technical key, which is usually the integer value over here. So this is for improving the performance, because storing the integer value which takes 4 bytes, whereas if you store the character value, which will take 8 bytes. So we will store it here. So this is how you will build your star schema. So querying from your fact table always requires a joins to your dimension tables, and you will get the respective results. If you want this product name wise, I mean, assume it's a chocolate, how much it has sold. So you need to join this fact table with this product table. Then you will filter it with chocolate. Then you will get the respective amount. So the aim of this video is to understand why you need to, how you will build the star schema, right? So I already made a videos related to what is star schema and why you need it in the Power BI itself. But now you see here how you can design it, right? Let us go to the AdventureWorks database, the OLTP system. In AdventureWorks we have some OLTP system, and in the data warehouse you will see how to create, I mean, how it is designed here, right? And how you are going to create this task schema, that I will cover it up after covering all the topics related to data warehouse. We will try to demonstrate using SSIS and with real AdventureWorks database or any other data set that we have. Now let us go to AdventureWorks OLTP system. So this is the business data where you can see here. I will save this diagram. Let us see here. You can see this OLTP system having different tables, right? You have from the sales module, you have n number of tables, and purchasing and production, then this person and human resource. So this is your business data. This is not your data warehouse. AdventureWorks OLTP system. This is to capture your business data. Now we have assumed like we were going to build this data warehouse for this AdventureWorks database, and one of the module we have taken considered as sales. So this is what we say as business process. So one of the business process is sales, another business process is purchasing, and another process is production and human resource. There are different business processes. Human resources, there is no way related to your sales, right? Maybe some persons in the human resource table, that is employee, is related here, but the whole process related to, say, I mean, salary or any other department related to human resource, not related to sales, right? So this is what you need to understand, what do you mean by business process. Then you can see here this tables how it is designed here. I have some database diagram here. Let us refresh. Excuse me. So you can see here the sales header is having header information. Then you have sales order detail, then it is related to product, then you have connected to salesperson here, sales territory. So this is basically typically ER diagram. You can ask me like this also looks like a dimension model, but slightly it differs in terms of dimension modeling. Is like you have sales order, and it is related to product, and it is related to some cyclic relationship also, you will get it here, right? So these kind of stuff you can see here. This is related to sales territory, again the salesperson related to sales territories. These kind of relationship you have. This design is not optimal for your querying. For querying you need to design in such a way that it is looks like a star schema. Now you can see here the same model related to sales is designed in data warehouse. In this module you can see the fact internet sales, that's it. Then it is related to date, promotions, currency, sales reasons. Then you have a product and subproduct and category. So this is typically a snowflake. This is not a star schema, but assume you have dim sales and dim product. These two or part of this, it becomes a star schema. So to demonstrate, I have shown this example. So this is typically a snowflake. Now for fact table, you can see this is fact table surrounded by different dimensions. So you need to transfer those design right over here into such a dimensional model. This is for one sales. Then again you can see for finance, you have typical star schema here. So fact, dim organization, scenario, dim date, department and account. So this is another dimension model for the finance module. So you don't need to think like a data warehouse can only one star schema. It is not the case. For each subject area, you can have multiple fact tables and a fact table connected to different dimensions. So in this case, internet sales having one fact table and surrounded by different dimensions. And you have a finance module where it contains its own fact table surrounded by 5 to 6 dimensions. So this is what it is. So your data warehouse will contain multiple fact tables. You can see fact call center, fact finance, fact internal sales. So each subject area you will identify, each subject area can contain multiple fact tables as well. In this case, the sales has only one, then finance has only one, different dimensions. So this is the design you need to come up with to create your data warehouse from your OLTP system. So this is what your star schema is, and all the examples we have seen only one fact table. So you think like data warehouse contain only one fact and different dimensions. Based on different business process, you have multiple fact tables and dimensions. I hope you understand the purpose of star schema, and it will be really quick when while querying when you join with the technical keys or the integer values. Or I mean, instead of joining with varchar, when you have this integer reference, your querying will be faster. That is the core aim of your data warehouse. If you like this video, hit the thumbs up button and comment below for queries. Do remember that data is your asset.